Hey everyone, we're going to take a look at numbers 7, 8, and 9 from section 4.3. We're given the graph of a function, and you need to be clear which function we're given in each of these problems. So in number 7, we're going to determine the intervals on which f prime, that's the derivative of the function, is positive and negative. We're going to do that, though, assuming that the given figure or graph that we have here is the graph of the function f, and only consider the interval from 0 up to 6. And they have some directions about how to enter the information, and I'll show you all of that. But keep in mind, this is the graph of the function. We're asked to find where the derivative is positive, where the derivative is negative. Well, you need to know that the derivative is positive when the function is increasing, or vice versa, when the function is increasing, then the derivative is positive. So if I want to know where the derivative is positive, I'm looking where the graph of the function is increasing. So it's clearly increasing. Again, we start at 0 up to what? X equal 1. So it's increasing from 0 to 1. And then it's also increasing what? From 3 up to 5. So that is where the derivative is positive. So I would do that 0, comma, 1. And then we need to do the little union symbol. That's what it says in here, to use the union symbol for combining intervals rather. And then from 3 to 5. I'm going to only use parentheses here, not brackets. We're talking about intervals where we're increasing, decreasing. So we're talking about a range of values. No need to include the endpoints in that. Where is the derivative negative now? Derivative is negative where the function is decreasing. It's going down from x equal 1 to 3, going down from x equal 5 to 6. So I'm going to put the interval from 1 to 3. Whoops. Need to put the parentheses there, not the number 9. From 1 to 3. And then from 5 to 6. We'll check our answer and go to the next question. So now we're going to, it looks like the same graph, we're going to determine the intervals on which the function f is increasing or decreasing. Now we're going to assume that the given figure is the graph of f prime. It's kind of like roles are reversed here now. So now this is the derivative, not the actual function. So remember the relationship. The function is increasing when the derivative is positive. So this is the derivative. When is the derivative positive? Well, it's positive when the graph is above the x-axis. Between 0 and 2, the derivative is positive, and between 4 and 6. And so those are the intervals where the function is increasing. So from 0 to 2, and then union from 4 to 6. Now, where is it decreasing? The function is decreasing when the derivative is negative. So when is the derivative negative? We see this is the graph of the derivative when it's below the x-axis, between 2 and 4. Okay, we'll check our answer there on that and move on to the next question. So again, the same graph, and now we have assume that this is the graph again of the derivative. So like the last one, this is now the derivative of the function. So what statements are true? Okay, so these are all statements you'll notice about the function f, and basically where we have local max mins or neither. This is not the graph of the function f. So for instance, you can't, f of 1 is the local maximum. Be careful, this is not the graph of f. F prime has a local maximum at x equal 1, right? Not f. So where does f have a local max or min given the derivative? Well, remember, by the first derivative test, that will occur at critical points. The max will occur when what? The derivative changes sign from positive to negative, and the local min will occur when the derivative changes from negative to positive. So do we have a local maximum at 5? Is f of 5 a local maximum? No, because at 5, the derivative is not even 0. the derivative has a maximum at 5, but the derivative is not 0. We do not have a change in sign in the derivative from positive to negative. I'm not going to check that statement. F of 2 is a local maximum. F of 2, the derivative is 0. We have a critical point at 2. And notice for values less than 2, the derivative is positive. For values greater than 2, the derivative is negative below the x-axis, right? So therefore, we're changing sign in the derivative from positive to negative. We have a local maximum at f of 2. F of 1 is a local maximum. Well, as I said previously, no. F prime has a local maximum at 1, but F does not, because that is not a critical point. F of 4 is a local minimum. Yes, because at 4, the sign changes from negative to positive in the derivative. This derivative changes from negative to positive at 4, and therefore we have a local minimum there. And then F of 3 is neither a local max nor a local minimum. So notice at this state, it's not a critical value, but if you think about it, from 2 to 4, what's happening? The derivative is negative. That means the function's decreasing all the way from 2 to 4. And so f of 3 is neither a max nor a minimum. Okay. And so we're going to check that box. Okay. And so there's our answers. Let's check and make sure that we're correct. And we are. So I hope this clarifies how to do these particular problems. And if you have questions about them, let me know.